This is how to use the sliding line method. So this method is used in further maths when you want to find the maximum or minimum values on a graph inside the feasible region. So if we have a graph, and let's say that this section in here was our feasible region. Alright, so how the sliding line method works is when you're given the objective function, the line that you want to measure, you would just take out your ruler or your pen, whatever you have, and you'd put your line in, and in this case, only the gradient matters. So the y-intercept doesn't matter. So if the y-intercept of the line was here, for example, it doesn't matter because you can move this line wherever you want as long as the gradient stays the same. So I can move it anywhere on my graph at all as long as I don't twist it like this. Okay, so for example, if my objective function was something like this, for example, and I wanted to find the maximum, I would have to slide up. And the last point that I pass is the point that is the maximum. So in this case, this point here is the last point that I pass. So this point is going to be the maximum. So let's do it as if it was a real question. All right, let's say that the constraints you had were that x is greater than 0, y is greater than 0, which just means that this y line and this x line, it's above those lines. And let's just say the constraints of these lines, 5 minus half x. Let's say the other line was y is less than 18 minus 3x. Profit equals 5x plus y. Now let's give some context for this. So let's pretend that you are a farmer and you're selling some fruits. Let's say y is the number of oranges you sell, for example, and x is the number of apples you sell. So the profit, let's pretend the profit is 5x plus y. So basically for every apple you sell, you get $5 profit. For every orange you sell, you get $1 profit. So that's what this equation means. So now to find the maximum profit you can get, you want to know how many apples and oranges you need to sell. So what we want to do is, there's two ways of doing it. So one is the method where you try each of these corner points and you just substitute that into this equation to find which one gives the highest profit. Or the other method, which I prefer, is the sliding line method. This is how you do it. So what you would do is, from this equation, you'd graph it as a line. Once you have your line, you can just slide it up or down depending on whether you want to find the maximum or the minimum. In this case, we want to have the maximum profit. So now the question is, how do we convert this into a line? How do I know if the line looks like this, like this, like this, you know? So this is what we do. This is the fast way. It's very simple. You just switch the axis. This is the shortcut, by the way. The longer way is to just move everything to the other side until you get it in the form of y equals mx plus c. So what that would look like is just rearranging this equation to get it in this form. Once you have it in this form, m is the gradient. So once you have the gradient, you can just put it in however the gradient is. But that is the long way. So I like to do this way instead. So this is the shortcut way. So switch axis, what I mean by that is, you find the intercepts by switching the coefficients next to these two numbers. So what that means is, right now we have 5 next to x, so I'm going to say that y equals 5 instead of x because I'm switching it. And right now we have nothing next to y. If there's nothing, it just means 1. So I'm going to say x equals 1. And that's the intercepts. Super easy, just switching the two coefficients next to each of them. So what that means is, I have my two intercepts of the line. So y equals 5, so this is going to go through that 5. And x equals 1, so we can just estimate 1 is about here. On your exam paper, it'll actually have each point labeled, so that'll be easy for you. But yep, so I know my line goes like this, goes through 5 and 1. But obviously, since this is the sliding line method, it doesn't matter where this line is. So we know it goes through 5 and 1, so that means this is the gradient. This slope here, that's the gradient we need to keep. Then I can just slide it up or down. In this case, I want to find the maximum profit, so I'm going to have to slide it upwards and see which is the last point that it passes through. All right, so keeping the slope the same way, if I slide it across, the last point I pass through is this one here, right here. And if I go back, you'll see that I've kept the same slope. This point here is going to give me my maximum. So what is the coordinates of this point? Well, we know it's on the x-axis line, so it's 6, 0, because y equals 0. All I got to do now is just substitute this into my profit equation. So then I have profit equals 5 times x, so 5 times 6, which is 30, plus 1 times y is 0, so just 30 plus 0, or in other words, just 30. And that is the highest profit that I know I can get. And that is how you use the sliding line method. So just to go over it simply, when you're given your graph with your feasible region, what you got to do is find the objective function, whatever that is, then use your ruler or your pen. I could even use my pen for this. Put in put it on the graph, and then make sure I'm keeping the same gradient and just moving it across. And whatever the last point is that I touch, that is the maximum. Or if I want to find the minimum, I would just go downwards. And that is all.